we have two guests here today. It's Dylan Gilbow and Jeff Pelletier. They're going to provide a presentation on PFAS treatment technologies for groundwater, focusing more on groundwater and wastewater. They're both from Evoqua. So CDM Smith and Evoqua work together. It's quite a bit, it's my understanding. So first of all, Dylan Gilbow has a BA in chemistry from Lake Forest College and has been in the water treatment industry for over 7 years, 5 of which have been focused on PFAS treatment in Illinois, Indiana, Missouri, Michigan, and Wisconsin for drinking water remediation and emergency response. Jeff Pelletier, who's joining him, is currently the Senior Business Development Manager for Emerging Contaminants at Evoqua Water Technologies. Prior to joining Evoqua, he has held several senior leadership positions with SGS, Pace Analytical, and Vista. He started his career in Portland, Maine in 1990 with the consulting firm EC Jordan and stayed with the firm for more than 16 years. That's now part of Wood. He has specific expertise in emerging contaminants, developing product development for analytical programs to meet the needs of the evolving markets. Mr. Pelletier has a BS in Business Administration with concentration in Sales and Logistics from the University of Maine at Orono, and has a minor in chemistry from Duquesne University in Pittsburgh. So thanks, guys. I'll turn it over to you, Dylan.
Excellent, excellent. And thanks for the great presentation, Zoom. I think it really did a good job of hitting home the importance of getting good analytical data, just because it is definitely pennies on the dollar for your ROI there. So let me see if I can get this slide change. Can everyone see my slide, Jason? Are you able to?
Yes, I can see it.
Okay, excellent, excellent. So I'm going to try to run through this as quickly as I can. I think the Q&A is going to be probably most important here, but I just want to give a brief overview of, who is Evoqua, get into our environmental solutions division, kind of do a brief overview of our PFAS solutions in-house, and then start talking design considerations, best practices, run through some case studies, and then get to the Q&A discussion. So Evoqua, we've gone through a number of different iterations. We probably have about 300 plus brands of water treatment companies that we have acquired over a 100+ year timeline. And really our core focus is bringing products, technologies, integrated systems and services to kind of approach water treatment in a holistic manner. And we bring that approach into a number of different markets. And what's really nice about this is that we're able to share best practices across different industries. So we're able to learn stuff from oil and gas industry and also apply that to drinking water. We have a number of different locations throughout the states. We've got a good amount in the Midwest. I think this map can actually be updated. We have some more manufacturing up in Michigan over in Ludington where we build some integrated systems out. We've got a number of carbon reactivation plants. The one closest is over in Darlington, Pennsylvania. We have 2 others out west. We also have a number of ion exchange regeneration facilities. One thing I do want to note, we do have 184 employees in Wisconsin through our branches in Milwaukee and Waukesha, and then we've got some other people kind of spread out across. We also have a number of different employees kind of spread out in states that are also actively dealing with PFAS. So really, we just want to say that we are heavily invested in ensuring clean drinking water and wastewater throughout the states for our employees as well. So the key difference in our division that's different from some of our other divisions is we kind of get full reign across the market to keep the nasties out of the environment. So we're the environmental stewards of Evoqua, and that kind of touches everything from 1,4-dioxane, nitrates, perchlorates, chlorinated solvents, all the way to PFAS. So jumping into our PFAS solutions and our efforts to maintain kind of an unbiased solutions-based approach, we try to make sure that we can supply any and all different types of PFAS treatment technologies. On this slide, I am missing the novel sorbents. We're also quite excited about fluorosorbent, some of the other technologies coming out in the market, and we're also actively testing and validating those different medias. Just kind of quick high level run through of kind of the pros and cons. Each activated carbon is a relatively cost competitive product. It also removes other co-contaminants. There's also an improvement on the taste and quality of your water once you use it. It does take up a large footprint. So moving to ion exchange, it's a much lower empty bed contact time, so much less space required. One thing that I will note is that we only supply single pass, so it's one and done usage, but it does end up being more competitive sometimes in certain applications, just because it can remove so much more PFAS than granular activated carbon. RO membranes, I always get the question, should we use RO membranes? I usually answer mostly no. The reject stream usually just concentrates up a PFAS stream, and it's another waste to deal with. We also can supply RSSETs. Like Zoom said, these are really great for getting, pretty good data. I wouldn't say, it captures everything, but it's a really good snapshot tool. You go on the order from months to weeks, if not days sometimes in some of these applications. We also have pilot skids available where we can load up various medias. We're not afraid to load up some of our competitors' medias in these. We just want to be able to supply the actual pilot to actually get it out there and collect data. We also have a big rental fleet of small vessels. So for quick need deployment, we've got rental assets on hand. We also have large, 10, 20, 30, 40,000 pound, even all the way up to 60,000 pound carbon absorbers. One plug I will put here is we've got a CIX, which is a carbon ion exchange product coming out, where we can basically build these tanks where you can change different medias over time and keep that changeover very easy to do, requiring minimal time to get inside the tanks. That way, if you do start and say carbon is the best solution at the time, but you fast forward a few years in the future and find that resin might be more effective due to supply chain issues, cost changes, then you can actually do that switch and make sure that your system stays optimized. So that's a key differentiator we have, is that we make tanks that can change between different medias, including novel sorbents. We also are able to integrate all of our systems onto mobile platforms and support them with operations 24/7. So I got a really nice case study I'll go through on these units here. Another thing I'd like to stress before I get into design considerations is just some of the structure and mechanisms behind PFAS compounds. So if you can see the carbon fluorine chain right here, we've got PFOA, the A chain. It's pretty long, then you've got all the way to PFBS, where that chain gets significantly shorter. As those chains get shorter, if you can think about carbon absorption like Velcro, right? The more surface area you have, the better it sticks to the surface area. So when you start to think about your design considerations, knowing which PFAS compounds you have present and which PFAS compounds you are treating to and be regulated on is going to be very key in designing your solution. Another thing to consider as well on the either the carboxylic acid or sulfonic acid chain head will be how that interacts with other anions in the water. I've got a little chart that kind of shows you where our resin is selective for certain anions. So it will be important to understand the concentrations of your chloride, sulfates, nitrates in your water, and understand how that will impact your resin performance. So as mentioned, design considerations, things we'll want to take into account when putting systems together. The contaminant profile, is this going to be something where you're going to get a lot of PFOA, PFOS? Is this going to be an AFFF? We're going to get a lot of PFHXS and some other telomeres. that'll be important to designing your system. The contaminant concentration, if we're talking part per million heavy loading, then you may want to look at film fractionation or some other solutions out there. Competitive absorption, if you've got other organic compounds out there that's going to compete with carbon, if you have a lot of other anions present, that will compete with your resin. Another thing, your pre-treatment requirements will also be important, especially in wastewater. If there is high TOC, high TDS, high TSS, you're likely going to have to put in some form of pre-treatment. So we like to look at bringing everything from sand filters to ultra filters to help kind of minimize the effect of the noise in those complex matrices of wastewater. Obviously, we'll look at flow rate, the total amount of water you're looking to treat, and how we're going to manage that. You know, is this going to be something where we want to just pull a small system out and have it run for a long time, large system, get it out and done really quickly with a high flow rate? So how I'm going to manage the total flow of the water will be important. And again, treatment targets, you know, treating to, 40 PPT combined PFOA, PFOS is going to be different than doing a sum total of 70 summative of 11 or 30 plus compounds. So understanding that will be very important. Also footprint also kind of relates to flow rate on the overall system sizing, and then timing and availability. I think the biggest thing I see out there right now is seeing what we have available on hand to treat those urgent needs. So sometimes you may say, you know what, ideally you might want large 40,000 pound carbon vessels, but we may need to go to 10,000 pounders and kind of make a farm of them. So it just kind of depends on what's on hand and what's out available in the market. So another thing I'd like to go on is just kind of our general approaches to remediation and emergency response. For remediation, I think of site investigation is going to be very important. So this is where you're really going to lean on your environmental consultants to really, determine the source, the actual size of the contamination, and have some good solid data where you can actually design a system around it and not have any surprises when you start running your system. I also think a good project team selection is important. Understanding, the best consultants out in the market, the contractors who are going to be working on these jobs, the vendors available, and the labs. You want to make sure that you've got a good team and that everyone's kind of singing together in harmony there. Again, you also want to think about the design considerations mentioned earlier. On emergency response, I really think one thing that a lot of people miss is containment of whatever water is contaminated. Typically, I see fire response as being the big kind of emergency response type application. So making sure you contain all that water, either being frac tanks, lake tank farms, anything like that, and making sure that you're not getting any migration offsite is very key. Also, your project team, I think you should do a good job of talking to the DNR, making sure that everything's transparent and that you're getting as much help as possible. And then also QA/QC validation. I think that is something that a lot of people miss. In these labs, they're testing down to the part per trillion levels for PFAS. So there's a lot of error that can pop up. So having a good QA/QC review is absolutely critical. And then just quick case studies. This one's a construction site, so sort of a brownfield type application where we had a contractor putting in foundation work and going below the water table. That's well points installed, and there was low levels of PFAS in the water. This was in a state that is very sensitive of any PFAS being put into any POTWs, any sewers. So the city actually said, hey, let's get some carbon treatment out there. And if you can see on the kind of top right area, we've got about 10,000 pound carbon units. We also have some pumps, some frac tanks, some bag filters, some pre-treatment to make sure the carbon does its job. And this was a site that we actually were there, I believe, over the summer, treating millions and millions of gallons of water quite successfully. So just kind of show how we can kind of respond, get out quickly, and get going and fully support it with an operations team. This one's a cool one. This is a Midwest automotive manufacturer that had a fire. They quenched the fire with AFFF foam, and then that water went into a waste sump and mixed in with about 500,000 gallons of water. So we worked directly with the client to put together a treatment scheme. We had some bag filters, some small carbon tanks. We loaded up with some specialty media that we knew would work well for carbon removal. One of the things that we did, focusing on that containment side, is we partnered with a local frac tank supplier to basically start pumping and treating into a small frac tank farm, taking samples of that water, having it validated in a lab to say, yes, it's clean water, before it was discharged into another holding tank. So we did that. We treated 500,000 gallons of water pretty successfully, but we did have some analytical come back with about 1.3 part per trillion of PFHXA. So luckily the person I was dealing with was also a chemist and understood that there's challenges at analytical that low. And I said, listen, let me reach out to a consulting chemist I know and have them take a quick look. And feedback I got from that consultant was, oh yeah, that's a common lab error. So got them connected, had a quick, great conversation, and they pushed back on the city's POTW, and they said, we don't care. There's PFAS in here. We're not taking it. So we actually went back to the board and said, hey, they asked us, would this be a good use for our fire water? And we said, absolutely, let's recycle it. So it was kind of a unique management of that treated water to make sure none of it goes off site. So now that will be used for future fire water purposes. Then just a quick wrap up. Again, we like to think of ourselves as a solutions provider, not an equipment or media provider. We enjoy working with consultants, contractors. I think working together as a team is very critical on these projects, because I know lots of people say they are experts. No one truly, in my opinion, is a true expert, because this is an emerging contaminant. There's still much to learn. There's still treatment technologies that are in development and validation. So I think keeping this as a team effort, I think, will be beneficial for everyone involved. We also will do everything from rental skids all the way up to these large permanent systems shown here. And we actually have a pretty good local network here in Wisconsin to help support folks treat PFAS. So open for questions. This is my contact for me. Feel free to shoot me any questions via email if you don't want to ask here. I think it'd be good to ask here to keep it nice and open. This is also Jeff's contact info as well. So thank you.
All right. Thank you, Dylan. So we do have plenty of time for questions here. Let's see here. Looks like we do have one here from Laura. I can read this to you. What are some of the common co-contaminants associated with AFFF sites? For example, chemicals associated with liquid fires, transformer fires, or products of incomplete combustion. Please include any unregulated contaminants that you know of in your reply.
Yeah, absolutely. So I've seen everything from oils, transformer fires. You can also see PCBs also being present. The biggest thing you really need to watch out for is just other organics, TFC, TSS. I've seen plenty of systems being deployed to site ready to treat millions of gallons of water, but have frequent carbon changeouts because they haven't considered solids fouling. Carbon itself will act as a 20 micron nominal filter. So you need to have at least 10 micron ahead of that carbon, or else it'll foul out. You'll be doing numerous backwashes. It'll be more of a pain than anything. So really considering the solids pretreatment is important. I think a lot for emergency and wastewater treatment. I don't see TOC and other co-contaminants being as big of an issue, especially organics, because carbon's also removing it. And you'll probably see PFAS breakthrough before you would some of those other co-contaminants. For ion exchange resin, there may be metals in there that might have an effect as well. You may have to look out for some other, anions that could jump out at you. But I would say keep an eye on solids. That's going to probably address 80 to 90% of the issues with emergency response.
Okay, we had a question coming through the chat. What happens to the PFAS and other contaminants after they are removed from the water?
So on carbon, it should be pretty well absorbed onto the surface of the activated carbon. From there, we can look at potentially reactivating that carbon through one of our kilns. Every waste profile is a one-time consideration. So we keep everything to a one-time consideration. If not, we can look at partnering with landfills. I tend to think dry landfills are a pretty good option out there with some of the issues we're seeing with incinerators. I also don't like deep well injecting. So we've got a number of waste management partners we talk to and kind of network with as this changes. But the PFAS compounds generally are bound up in carbon or tied up with the resin. And I will say our resin, we do not regenerate. There's some issues there with what you need to use as a regenerant. So we tend to just stick with single use because it's less waste. It's easier to manage long term.
Okay, the next question came in through the chat is if you landfill the carbon or resin, can't it just end up back in the water table?
That's a question I'll leave more for a waste management company, but I'll take a stab at it. I really like the concept of dry landfills. This is mostly out west in desert facilities where you're not generating, a leachate out there. So I tend to think that's the best option right now beyond, reactivating carbon.
Megan, this is Jeff here. I didn't see the question come through on the chat, but maybe the person asking the question, is it related to the fact that when you're removing with either GAC or resin single pass, you're kind of moving the contaminant from one place to another and then taking it to the landfill, then what? Is that what the person's asking?
Yeah, I get the impression that that's kind of what, you've removed the PFAS contamination from one place and then you still have this leftover contamination. So what do you do with that, those items at that point?
Okay, I mean, the jury's still out is really the answer. The best practice right now in the options that we have available out in the marketplace is that it has to go off to disposal. And as Dylan just mentioned, is it landfilling? Is it incineration? Are these great options? No, but it's the option that we have today. I think where you're going to see where we didn't see 5 years ago in this market is maybe a final step after we've removed with either GAC or resin is some type of destruction technology. And we've got a deep bench within Evoqua where we're evaluating lots and lots of technology companies, if you can imagine, that have come to us and work with our R&D team every day. So I will say the future's bright. There's some great new technologies out there. You're probably reading about them. You probably see them at conferences, and it's coming soon. So
this is Jason. Just a comment. Yeah, that's a common concern that a lot of people have. So that's a good question. The landfills are designed. They do have liners in them to help, and engineered liners to help prevent groundwater contamination. But I think maybe one of the bigger concerns is, since it does tend to recycle through the environment, it ends up in the leachate. So in theory, it shouldn't get to the groundwater, but even if it doesn't, it ends up in the landfill leachate. And then, that a lot of the wastewater treatment plants don't want to deal, or they're not equipped to deal with that leachate. So for that reason, a lot of landfills don't want to. I think that's one of the main reasons a lot of the landfills don't want to take concentrated PFAS waste.
yeah, that's correct. And I mean, there are, you know, we work with a few companies, and our clients work with a few companies that do take it right now, and they are willing to handle it. But for the most part, you're right. People don't want to add it to their landfills to make it more of a problem or add to their problem that exists. And as you said, it does. It all ends up in the leachates at some point.